Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the coefficient of restitution and recoil of gun. The outcome of this session would be recall the concept of conservation of momentum for knowing the velocities and momentum before and after collision of bodies. Topic covered would be coefficient of restitution and recoil of gun. Topic learning outcome is understand the concepts of impulse and momentum and apply these in the collision of bodies. First, let us see what is the coefficient of restitution. During collision, the colliding bodies initially undergo a deformation for a small time interval and then recover the deformation in a further small time interval. As we have discussed in the introduction of this topic, the collision or impact of two bodies is said to be an impact when these two bodies exerts some force, very huge force for a small interval of time over one another. So the collided bodies, first body would be exerting very huge force onto the second body for a very fraction of second, and then again the second body will exert a huge force on the first body for the same small interval of time. So the whole scenario, as we have discussed previously, can be divided into two cases: before collision and after collision. Before collision, the two bodies will be getting into contact with each other and gets into contact with each other with the exertion of the force. The first body exerts huge force on the second body and second body exerts huge force on the first body. And in this scenario, what happens? The deformation of the bodies takes place. While the execution of the forces are happening on one over the other bodies, the deformation of the bodies will happen. So, the deformation happens nothing but the contraction or expansion of materials happens for a small interval of time. So, the time when this small interval of time when the deformation is executed, that means the contraction of the bodies takes place. This is called as the first stage. And after certain time, because of the elastic properties of the material, again what we have discussed, that the deformation will try to recover. That means after complete deformation, maximum limit of the deformation, the bodies will try to recover the shapes. That means again they will try to separate with each other. Like if you take an example of two footballs, let us say two footballs having less air in them, slightly not fully inflated but slightly less air in them, and we try to throw the two footballs to one another, then what happens? The footballs will come into contact with each other and they will try to compress one over the other. And after compression, again, because of the elastic property, they will again try to separate themselves. Right? Once the contact point of the two bodies starts, that would be the starting point of the impact, and the deformation of the bodies happens because of the less air in them. The deformation of bodies happens for the maximum permissible limit. Maximum limit, they will be deforming, and then after the maximum limit, again they will try to separate themselves by the elastic property of the materials. That separation of the bodies will also happen to a small interval of time at the point where the two bodies get separated. At the point where the two bodies get separated, that is the end point of the impact. So, the starting point of the impact would be the contacting of the two bodies point, and the ending point of the impact would be the separation of the two bodies. So, in between the compression or contacting of the bodies and separation of the bodies, there would be a small interval of time. In that time, there are two phenomena that are happening. So, these phenomena which will be happening before the complete compression or deformation of the object and after the deformation of the objects or the bodies are termed as the two cases. So, during collision, the colliding bodies initially undergo a deformation for a small interval of time and then recover the deformation in further small interval of time. So the period of collision, that is time of impact, consists of two intervals. The first one is period of deformation, where the time lapse between instant of initial collision to the maximum deformation, as we have discussed, the contact point, the starting of the contact point, and maximum deformation or maximum permissible or allowed or maximum limit at where the deformation is max is called as the period of deformation. In that period of deformation, the contacting of the two bodies will start and they will deform to a maximum extent. And second one is the period of restitution, where the time elapsed between the instant of maximum deformation condition and the instant of separation of the bodies. As we have discussed, the second case, where from the maximum deformation position, the separation, and then they will try to retract their original shapes, and after certain time, after small interval of time, they will try to separate. That point where the two objects are separating, that would be your end point of the impact. So that time from maximum deformation to the separation point is called as the period of restitution. So for the coefficient of restitution to be understood, let us see the example of two bodies that are being impacted or that are being colliding with each other. Let M1 and M2 are the mass of first and second bodies. The bodies are A and B here, and the two bodies are traveling with initial velocity before impact with the U1 and U2, and after impact the bodies are again traveling with velocities V1 and V2, let us say, and the line of impact is direct here. U1 and U2 velocities of first and second bodies before impact, and V1, V2 are the velocities first and second bodies after impact. The coefficient of restitution of two bodies moving and colliding with each other is defined as the ratio of velocity of separation to their velocity of approach. So the ratio where the velocity of separation and velocity of approaches are taken, that ratio is called as the coefficient of restitution. As we have seen, the time period of restitution is the time period when from the maximum deformation of the bodies to the separation of bodies happens. So if U1 is greater than U2, then collision happens, right? As shown in the figure, the two bodies will get collided only when the U1 is greater than U2. If at all U2 is greater than U1, what happens? The U2 will be moving forward and U1 will not catch up with U2. That means A and B bodies. Same case, if U1 is greater than U2, then only the impact will happen. So we are considering that. If U1 is greater than U2, then the body A will collide with body B. Velocity of approach would be U1 minus U2. So the difference of the velocities is U1 minus U2. And if V2 is greater than V1, okay, when V2 is greater than V1, then only the bodies will separate themselves and they will be moving in the forward direction. Then the body B will separate with A. So we can say the velocity of separation is V2 minus V1. Therefore, the coefficient of restitution represented with letter E is given as V2 minus V1 by U1 minus U2. The same terminology, the same term, same equation that we have derived in the Newton's law of collision. Okay, this is the ratio of velocity of separation to the velocity of approach. Now, for the same case of collision, what happens? There are three cases that we need to consider. One is completely elastic body, one is partially elastic bodies, and one is perfect plastic bodies. Right? We need to understand what these three cases are. Perfectly elastic bodies are the bodies where once the deformation happens to the body, the recovery of the shape or regaining of its original shape happens completely. Like, take an example of a rubber band, let us say a rubber band. If you try to elongate the rubber band, it will expand. That means the shape has been deformed. When you release this rubber band, it will get completely to its original shape. It will regain its original shape completely. right? So we can say that this rubber band is the perfectly elastic body. Likewise, as the previous example where we have considered two footballs having less air in them, there also, when you throw this less air-filled football on the ground, the deformation happens. But once you release that football, what happens? It will again get its round original shape, right? So we can consider that as the perfectly elastic body. Whereas partially elastic, these partially elastic bodies are the bodies which are practical in nature, where we are observing many materials. Let us say some steel wire. Let us say some steel wire or some tempered wire, where we try to bend this tempered wire bar. Let us say, when we try to bend this bar, it will try to move to its original shape, but won't recover to completely to its original shape, right? When we try to bend a wire, a rod, maybe some 2 mm diameter rod, when we try to bend it, some tempered rod, then what happens? It will try to again go to its original shape, but it will not completely recover. So these type of materials can be considered as the partially deformed or partial elastic bodies. And the next one would be plastic bodies, where the elasticity will not happen for even a small type also, for small consideration criteria also. After deformation, there won't be any recovery. Like the best example would be a stick. Let us say, when you try to deform the stick, it will break completely, like some brittle materials, right? It will break completely, but won't get to its original shape. Or completely soft material, soft aluminum rod. Let us say a soft aluminum rod. When you try to bend the aluminum rod, it will bend, but it will not even try to come to its original shape. It will be like the deformed shape itself, right? So these are the complete plastic objects. Okay, so for these types of three cases, we are going to see how the coefficient of restitution is going to be. So first, as the first case, let us see the perfectly elastic bodies, which is called as the elastic collision. For the perfectly elastic body, the coefficient of restitution E value would be 1. Where the velocity of separation is equal to the velocity of approach. Hence, total energy is conserved. Thus, kinetic energy before impact is equal to kinetic energy after impact. So this can be given with the equation half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So the total momentum is also conserved here. So we can write momentum before impact is equal to momentum after impact. So for this, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. And for the second case, the perfectly plastic bodies, we can say it is the perfectly plastic bodies, and it can be called as the inelastic collision. Inelastic collision. For this type of situation, E is equal to 0. That means the coefficient of restitution is equal to 0. Why this 0 is coming into picture? Because after collision, there won't be any recovery of the material. That means both the objects will be attached themselves. Once the collision happens, the deformation happens, both the objects will be getting into contact with each other, and they won't be recovering their shape. So what happens? The final velocities of each objects would be 0. The both will be combinedly moving. That means there won't be any difference between the final velocities of these two objects. The final velocities of the objects is same. So V2 is equal to V1. Hence, we can say that V2 minus V1 would be 0. That's the reason the coefficient of restitution E would be 0 by some U1 minus U2. So that will be answer as 0. Hence, for inelastic collision, the value of coefficient of restitution is 0. Both bodies stick together after impact and move with common velocity. So the total momentum before impact is equal to total momentum after impact. Hence, we can say it is m1 u1 plus m2 u2 is equal to m1 plus m2 into v. There will be loss of kinetic energy due to impact and is dissipated in the form of heat and sound. So the energy which is being involved in the movement of the objects and after collision, the energy will be dissipated in the form of heat and sound. The loss of kinetic energy is given by half m1 u1 square is plus half m2 u2 square minus half m1 plus m2 into b square. Now for partially elastic bodies, which is the third case, E is equal to 0.22 just less than 1. Total momentum is conserved and velocity of approach is not equal to velocity of separation. These are the practical situations. Now coming to the recoil of gun. When a bullet is fired, it leaves the gun with a certain velocity and the gun moves backwards. The backward motion of gun is called as recoil. For this recoil of the gun, we will be having an equation that would be derived here. Let m is equal to mass of the bullet and m is equal to capital uppercase letter m is equal to mass of gun. U is equal to velocity of the bullet leaving the gun and V is equal to velocity of recoil of gun after firing, that is after impact. Before firing, both the bullet and gun are at rest. Therefore, sum of initial momentum is equal to 0 and momentum of bullet after firing is equal to mu. Hence, momentum of gun after firing is equal to uppercase letter m into v. So, we can say sum of momentum after impact is equal to mu plus minus mv. Hence, from the law of conservation of momentum, we can say mu minus mv is equal to 0. Hence, from this we can write v is equal to mu by m, where v is the velocity of recoil of the gun after firing. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.